In this video, let us talk about remaining two chemical properties of haloalkanes. The second chemical property of haloalkane is elimination reaction. This reaction also we have learned already in class 11 hydrocarbons. So, alkyl halides, when you treat with alcoholic KOH, it undergoes beta elimination. Anyway, we call. So, the halogen atom to which the carbon atom is attached, or the carbon atom to which the halogen atom is attached, is alpha carbon, and the neighboring carbon atom is called as beta carbon. So, it undergoes beta elimination, which means the chlorine from the alpha carbon and hydrogen from the beta carbon will eliminate, and remaining will form alkenes. So, it will produce like this. Reaction will take place like this. So, this is elimination reaction. If there are only two carbon atoms, then no issues. When you see this particular compound, 2-bromopentane, here now bromine is at the middle position, the second position. So, this will also act as a beta carbon. This will also act as a beta carbon. Then which particular product is going to be major product? So, I have written two products on either sides. Now, what will happen is this, when you consider this as beta carbon, so what will happen? One hydrogen will go and this bromine will go, resulting in the formation of CH double bond CH2. So, it will be in the first position. Double bond will be in the first position when you consider this as beta carbon. Similarly, when you consider this as beta carbon, what will happen? Bromine from this carbon atom will go, and similarly one hydrogen from this carbon atom will go. Thus, resulting in the formation of CH3, CH double bond CH single bond CH2, CH3. So, this is again, so this is going to be a major product. Why am I calling this as a major product? Why? Because the one rule says that during beta elimination, there has to be greater number of alkyl groups on either side of double bond. When you take in this case, there is only one alkyl group to the one side of double bond. So, this is not going to be a major product. But here, when you see on either side of double bond, you have two alkyl groups. So, this is going to be a major product. So, in case of you have two beta carbons, the carbon atom, or you will choose one as a major product which has greater number of alkyl groups on both the sides of double bond. This is about elimination reaction. Third one is reaction with metals. Reaction with metals, when you see alkyl halides on heating with metals in presence of dry ether, will give you RMX, that is organometallic halides. So, one such example is CH3Cl plus Mg in presence of dry ether will give you CH3MgCl. All these organometallic halides are called as Grignard reagents, and one such famous Grignard reagent is CH3MgCl, that is methyl magnesium chloride. And all these Grignard reagents, they are highly reactive. Why are they highly reactive? Is because it has both ionic and covalent bond. When you see CH3MgCl, it's again partial negative charge, partial positive charge, partial negative charge. So, it will have both ionic bond as well as covalent bond. This is going to be ionic, this is going to be covalent bond. So, that is why they are highly reactive. It is unstable, so they are highly reactive. And what is the use of dry ether here? Use of dry ether is, since alkyl halides are highly reactive, they will even react with the protonated water. Say you have one proton, you have some medium, this is one medium. In this medium, you have CH3X, and if there is one proton here, automatically this will abstract proton forming hydrocarbon. That is why we use dry ether. Dry ether will not allow the reaction between alkyl halide and any bonds. So, this is about reaction of haloalkanes. Elimination reaction, reaction metals, you have Grignard reagents. And let us pass on to the last topic of the chapter, which is reaction of haloarenes, chemical properties of haloarenes. First one is nucleophilic substitution reactions. Generally, nucleophilic substitution reactions in benzene ring will take place at drastic condition because of resonance. It will attain partial double bond. It is very difficult to cleave that partial double bond. So generally nucleophilic substitution reactions will take place under drastic conditions. So nucleophilic substitution reactions is done by a process called as Dow's process. So Dow's process is chlorobenzene on treating with NaOH in presence of 623 Kelvin and 300 atmospheric pressure will give you sodium pentoxide. And when you take this with H+, you will have OH. Now, when there is nitrobenzene, chloro-nitro, when number of NO2 groups increases, the drastic conditions will increase because it will take electrons from the benzene ring. So, electron withdrawing groups, it will take electrons. So, automatically thing will increase. So, Dow's process is nucleophilic substitution reaction. So, chlorobenzene on treating with sodium hydroxide in presence of 673 Kelvin and 300 atmospheric pressure will give you sodium pentoxide. This on treating with H+, you will get phenol. So, this will act as a nucleophile OH to go and try to abstract this oxygen to remove. This is Dow's process. Now, electrophilic substitution reaction, the first one is halogenation. Last year we have learned with benzene ring, but here we have with chlorine. So, same thing, chlorobenzene on treating with chlorine in presence of anhydrous AlCl3, you will get two products. So, one chlorine will occupy the ortho position, another chlorine will occupy the para position. However, this is going to be a major product and you can separate these two by steam distillation. This is one technique for separating these two compounds. Okay. So the next chemical property of haloarenes is nitration. So all these electrophilic substitution reactions we have learned in hydrocarbon chapter in class 11 without any substituent. But here we have substituents and so. So now first one I have already done halogenation. Second one is nitration. So chlorobenzene on treating with NO2 in presence of concentrated H2SO for concentrated HNO3, you will have same way you have two products, one in the ortho position, another one in the para position. So this is going to be a major product. You separate these two by steam distillation. Similarly, sulfonation, chlorobenzene on treating with concentrated H2SO4 and SO3. So it will give you two products. In ortho and para, you will have this as a major product. You can separate these two by steam distillation. Now, one new reaction is Fittig reaction. Fittig reaction is same way like this reaction. Two molecules of that is haloarenes with two molecules of sodium, two sodium atom in presence of dry ether, you have diphenyl. Same like we learned in this reaction. So, two molecules of chlorobenzene with two atoms of sodium in presence of dry ether, you will have formation of diphenyl. Next, last reaction is Wurtz-Fittig reaction. So, combination of Wurtz reaction with Fittig reaction. CH3Cl, 2Na, chlorobenzene in presence of dry ether, it is CH3 plus, toluene plus NaCl. Fittig reaction means chlorobenzene, sodium. Wurtz-Fittig reaction means CH3Cl, sodium, chlorobenzene, remember dry ether. So with this the chapter is over. So in this lesson we have discussed about haloalkanes and haloarenes, its classification, its physical properties, then its preparation, and its chemical properties. So the important things is about all the naming reactions starting from Finkelstein-Schwarz-Sandmeyer's reaction, then you have Dow's process. These are the naming reactions which are important. I have mentioned only few. And at the same time we have to know about the mechanism, that is SN2 mechanism and SN.